Okay, today we're going to learn about the sine, cosine, and tangent ratios. Once we learn those, we're going to use them to solve problems. So you can look at our learning goal there, and if you want to pause it for a moment, you could write that down. Okay, think back to what we just talked about with similarity. If you look at these two triangles, we have triangle ABC right here, and we have triangle DEF over here. They are similar to each other, and hopefully we're all recognizing or realizing that it's by angle since we just talked about that. So we know that triangle ABC is similar to triangle DEF. Okay, so up above it's asking us what is the ratio of AC to AB? So we want to compare AC, which is down here, to AB, which is up here. Well, we know since the triangles are similar, it will have the same ratio as the side on the other triangle as the sides. If we take DF to EF, we can see right there that it's 3 to 4. So the answer to number 1 is the ratio is 3 to 4. Okay, you'll get a second, what is BC to AD? Okay, now we're comparing this leg over here, okay, to the hypotenuse over here. So if I look at my other triangle, that would be the same as taking EF to ED, which you can see right there is 4 to 5. Okay, last question up there saying, what is BC to AC? So look over here, that's comparing this leg of the triangle to that leg of the triangle. So if I come over here to the similar triangle, that'd be the same as comparing that leg to that leg, which is 4 to 3. Okay, the idea behind this is if I have triangles that are similar, those ratios will always come out to be the same thing. So when we talk about sine, cosine, and tangent, what we're doing is saying that certain angles, for example, this angle A of 53 degrees, corresponds to certain ratios. So it doesn't matter, if you look over here, this angle is also 53 degrees. The ratio of the opposite side to the adjacent side was 4 to 3. Now that's the same thing we got over here when I compared the side opposite that angle to the side adjacent to that angle. So certain angles in right triangles have certain ratios that go with them. And these ratios have names, and that's what we're learning today. They are the sine, cosine, and tangent. So go ahead, and I want you to draw a right triangle similar to this one. Follow along with me and take notes. If you need to pause it while you go, you can. We're going to name those different ratios. So I have this triangle ABC. Let's make it a right triangle. So make it a right triangle. Then I need to pick an angle to use, and so I can either pick angle A or angle C. I'm going to choose angle A. And we're going to write down those 3 different trig ratios. So the first trig ratio is called the sine of A. So write this down in your notes. We have the sine of A. We have an abbreviation for that just to make it easier to write. So if I want to write the sine of A, I can also write that as being, that also means the sine of A. We do not say the sin of A. Okay, the sine of A is the ratio of the opposite side to the hypotenuse. So I'm going to come over here and label this triangle. So come over to the triangle. This is considered to be the opposite side. So you notice that it's across from the angle A. This is considered to be the hypotenuse. Side AC is, as it's the side opposite the 90-degree angle. We're actually going to call this side down here the side AB at the bottom, the adjacent side. So if you want to label all those 3 of those sides, so we got hypotenuse, the opposite side, and the adjacent side. You'll notice that the hypotenuse is also adjacent to angle A, but it already has a name, so we don't call it that. Okay, so the sine ratio is really simple. If I just take the opposite side over the hypotenuse. Okay, that gives us the ratio, the sine ratio. Okay, the opposite over hypotenuse. The second trig ratio is the cosine. So if we say we want to find the cosine of A, we can abbreviate that also. Looks like this. Do not say the cos of A, it's the cosine of A. And it's equal to adjacent over hypotenuse. All right, so the last trig ratio is the adjacent, there's the tangent ratio. So let's write that down, spell it like this. We have the tangent of A. And the abbreviated way to write it is like this. Okay, we don't say tan, we say the tangent of angle A. And it is equal to the opposite side over the adjacent side. So those are our three trig ratios. And it doesn't matter, I can take this triangle over here, I can take triangle ABC, and if I shrink it, right, even though as long as I do it as a dilation, either enlarge it or shrink it, that triangle will still have the same ratios. And so for the same angle, for this angle A over here, the ratio of this triangle, no matter how big or small it is, as long as the angle is staying the same and it's a right triangle, those ratios will stay the same, that sine ratio, cosine, or tangent ratio. So we're going to practice over this next little bit just going through and finding all three of those, the sine, the cosine, and the tangent ratio. This is what it shows you in the book. It's really the same thing we just said. So if you look at it, sine equals the opposite side over the hypotenuse. The cosine is equal to the adjacent side over the hypotenuse. And then down at the bottom here, you can see that the tangent is equal to the opposite side over the adjacent side. Okay, as you go down through that. Oh, one thing I was also going to mention, if I go back here for a second to this triangle. So we had this triangle ABC, right? So we go back here, just enlarge it again there. Something important is it does matter which angle you're coming from. So if you look at it, if I switch, and instead of saying angle A is my angle, if I come up here and say angle C is my angle, look how that changes the triangle. Now instead, this is still this side is still the hypotenuse. But if I look at it, this side down here is no longer the adjacent side. So I'm going to take this adjacent side, and this side up here becomes the adjacent side. This side now becomes the opposite side when I go down to there. So it does matter which triangle you're looking at. It does matter which is, we call these the reference angles. If I'm using angle C, or if I'm using angle A, that changes which side is the opposite and the adjacent side. So keep that in mind as we go through these examples. All right, so here's our first one. It says find the sine of S, the sine of R, the cosine of S, and the cosine of R. I've got a triangle over here. So let's start with the sine of S. Okay, so if I want to find the sine of S, what I would do, I think it's always helpful to figure out which is your angle you're looking from. So this is my angle up here. I'm going to circle it. Angle S is the angle I'm using. And now I'm going to label my sides. So 65 would be the hypotenuse. 63 is across from angle S, so it is the opposite side. And 16 is next to angle S, so it's the adjacent side. If you label your sides, the rest of this is really easy. Okay, now it's just a matter of knowing what the sine of S is equal to. The sine of S is equal to, the sine is opposite over hypotenuse, so it would be 63 over 65. The problem says write it as a fraction and as a decimal. I'm just going to write it as a fraction. So we could plug that in a calculator if you wanted to, 63 divided by 65, and change it to a decimal. The cosine of S, okay, cosine is the adjacent over the hypotenuse. So I come over here, that means it's 16 over, and the hypotenuse is 65. Sorry, my board's being a little funny there. So 16 over 65. Okay, it also wants me to find the sine of R and the cosine of R. Let's find those two. Okay, now when I go to find r, it's changing. So now instead of s being my angle, r is now my angle. 65 is still the hypotenuse, but now the 16 becomes the opposite side, and the 63 becomes the adjacent side. So when I go to find the sine of r is equal to the opposite over the hypotenuse, which is 16 over 65. And the cosine of r is equal to the adjacent over the hypotenuse, which is 63 over 65. Okay, so there's the sine of r, cosine of r, sine of s. And I want you to notice up here that because when we switched from angle s to angle r, we switched the opposite and the adjacent side. You'll notice that the sine and the cosine of the two angles just switched places, and the cosine and the sine of the two angles just switched places. It's kind of interesting. We'll talk more about that here in just a second. Let's do a tangent. So here's a different problem. It wants to find the tangent of s and the tangent of r. So again, start with what angle you're starting from. So if I'm finding a tangent of s first, I'm going to start up there. Label your sides. This is the hypotenuse. This is the opposite side. This is the adjacent side. Okay, look up your trig ratio for tangent. Tangent is opposite over adjacent. So my answer is 80 over 18. We could take that fraction and reduce it. If we wanted to, like it says here, we could switch it to a decimal by dividing it. Okay, next we're going to do, though, the tangent of r. Okay, so I got to change my perspective now. So now I'm over here. This is now my angle. So the 18 is now my opposite side. The 80 is now my adjacent side. The hypotenuse never changes. Okay, tangent again is 18 over 80. So opposite side is 18, adjacent side is 80. There's my answer right there. Okay, as a quick side note, there is a way to remember these trig ratios because we're going to have to memorize them. You've got to know the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So there is a way. It's been around forever. I'm sure your parents, if you ask them about it, remember this also. But this, if you want to write this down, SOHCAHTOA. This is just an abbreviation that helps us remember, right? So this stands for the sine of the angle equals the opposite over the hypotenuse. The cosine of the angle equals adjacent over hypotenuse. The tangent of the angle equals opposite over adjacent. So if you have that written, if you go to work on an assignment, if you want to write that at the top of your paper, that can help you remember what those are equal to. Okay, let's go through. I'm going to skip past these. If you want to pause it and try these. That just makes your heart warm, right? When you hear the bell there, like school's supposed to be starting here. So, but if you want to pause this and try these, this is what we just did, right? It wants me to find the sine, cosine, and tangent of j and k. I'm going to write down the answers, at least to number 1, so you can check it. But if you want to pause it before you do that and work it out and try it just to see if you've got it, you can. So if I'm doing this sine, I'm just going to do the sine, cosine, and tangent of angle j. So this would be the opposite side. This would be the adjacent side. This would be the hypotenuse. So start with the sine of angle j is equal to, if it's helpful, remember, write down that SOHCAHTOA. So if you look up there, sine is opposite over hypotenuse. So the opposite side is 24. The hypotenuse is 40. And again, if you want to reduce that fraction, you can, or write it as a decimal. You could plug it in a calculator. The cosine of j is equal to, the cosine is adjacent over hypotenuse. That'd be 32 over 40. And the tangent of j is equal to opposite over adjacent, which is 24 over 32. And normally we'd reduce those, and you can if you want, or you can change them to decimals. So if you want to try number 2, I'm going to skip past that, but you're free to, just to make sure you got those 3 trig ratios down. Now, one of the main reasons, or probably the main reason we learn sine, cosine, and tangent is that it allows us to solve triangles. So if you take for just a second and look at this triangle, I got this triangle, it's a right triangle. The one angle is 26 degrees. We know the hypotenuse. I'm going to label it. The hypotenuse is 14, and we're trying to find x and y. We cannot solve this with Pythagorean theorem because I have to know 2 of the 3 sides, and I only know 1 of the sides. We also can't solve it. This is not a special right triangle, if you remember that we just learned about a 30, 60, 90 or a 45, 45, 90, so we can't solve it that way. So what we can do instead is we can use those trig ratios. So let me show what I mean. Let's start by solving for x. So if I know this angle over here, so if you want to circle that angle, that's going to be my angle. And then I'm going to label the x side. The x is the opposite side. The y is the adjacent side. So what I have to do is I have to pick one of the 3 trig ratios and use it to solve this. So if I'm looking at the trig ratios, we got sine, cosine, and tangent. So if I want to solve for x, I could use this side, I need to use this side, and I need to use the side I know, which is the hypotenuse. So I need to choose one of those trig ratios that involves the opposite side and the hypotenuse side. So if we look up here, sine is opposite over hypotenuse. So I'm going to say the sine of 26 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 14. So now I've got an equation there I can solve to find out what x is equal to. So to get x by itself, I have to get rid of the 14. So I'm going to times by 14. That reduces down to be 1. I'm going to times by 14 over here. So x is equal to 14 times the sine of 26 degrees. Well, I know what 14 is. The sine of 26 is some trig ratio. I don't know what the answer. Like, I don't have all those memorized, right? But that's where we have calculators. So if you grab either a graphing calculator or a scientific calculator, you'll notice there are 3 buttons that say there's a sine, a cosine, and tangent. As a side note, make sure you look at your mode, and in the mode you can actually switch between 2 different measures. You can do degrees or you can do radians. So check your calculator and make sure it's set to degrees. So if you hit the mode button on your calculator, whether it's a graphing or scientific, make sure it's set to degrees. And then I'm just going to plug into my calculator. I'm going to go 14 times, and I just plug in the sine of 26, and it will find that for me. It knows what the sine of 26 degrees is. I hit enter. All right, school's actually starting now. I hit enter though, and it comes out to be 14 times the sine of 26 degrees, comes out to be 6 point, let's see, this is the nearest tenth, so I'm going to round it 6.1 is what x comes out to be. So we know that up here, that side right there, this x right here is 6.1. Okay, now we're going to go back and solve for y. So to find y, I come down here. Y is the adjacent side. So now I want to come up with a trig ratio that involves the adjacent side and a side that I know. I could use x, but x is a rounded number, so it won't be as exact. If I use the hypotenuse, it's an exact number. So I want to do adjacent and hypotenuse. So if I come up here, the cosine is the adjacent and the hypotenuse. So my equation is going to be the cosine of my angle 26 equals the adjacent side, which is y, over the hypotenuse, which is 14. Okay, now I just need to solve that equation. So all I'm going to do is times by 14, times by 14. Plug that in a calculator, so grab the calculator again, find the cosine button, and we're going to go 14 times the cosine of 26 degrees. And I get, for that one, that y is equal to approximately 12.6 is my answer. So using those trig ratios, we can solve for x or y. Okay. Let's do one where we have to use the tangent. So here's another triangle. I've got this triangle. My angle is 32 degrees. Label your sides. This would be the opposite side. This would be the adjacent side. So again, I'm thinking SOHCAHTOA. So I got the opposite. I know the opposite. I'm trying to find the adjacent. So it's going to be the tangent. So I'm going to go the tangent of 32 degrees equals the opposite side, 11 over x. Okay, so the tangent of 32, our calculator knows that, but this is a little bit trickier because the x is on the bottom of the fraction, so you need an extra step here. So I'm going to times by x to get it off the bottom of the fraction. That's 1. It goes away. So now I have x times the tangent of 32 equals 11. Divide by the tangent of 32. It reduces down. Divide by the tangent of 32. That's going to be my answer right there. So grab a calculator. We're going to plug that in. We're going to go 11 divided by the tangent of 32, which comes out to be 17.6. So that's my answer over here. X is equal to 17.6. We got our answer. So there's an example using sine, cosine, and tangent to solve a triangle. Okay, this one's a little bit different. It says use a special right triangle to find the tangent of a 60-degree angle. So I'm just going to draw a right triangle here. So draw a right triangle. We want it to be our special right triangle that has a 60-degree angle. So just a reminder, we got 30, 60, and 90. It doesn't matter how big or small you make the measures of the sides of your triangle. So we're just going to pick one. I'm going to say that this side, the short side, is 1, but you could call it 2 or 3 or whatever you want. Remember, if I know the short side, the hypotenuse is always double that. So the hypotenuse would be 2. And then the long leg is you take this side and times it by the square root of 3. So it'd be 1 times the square root of 3, which is really just the square root of 3. Okay, it wants me to find the tangent of a 60-degree angle. So here's my 60-degree angle up here. Remember, tangent is the TOA. So tangent is opposite over hypotenuse. So I take the opposite side, which is right here, square root of 3. Over the adjacent side, which is right here, which is 1. And there's my answer. The tangent of 60 degrees is equal to the square root of 3. So we can evaluate sine, cosine, and tangent of those special right triangles without even having it. We can draw our own triangle and we can find the lengths of those sides. Here's another one. Find the sine and cosine of a 45-degree angle. So here's my special right triangle. I didn't draw that very well, but we'll say it's a 45 triangle. If I say the legs are both the same, it's isosceles, right? If they're both 1, to find the hypotenuse, you times by the square root of 2. So it'd be 1 times the square root of 2, which is really just the square root of 2. Okay, pick a 45-degree angle to be your angle, your reference angle. If that's it, we're trying to find the sine and cosine. Sine is opposite over hypotenuse. So sine of 45 equals the opposite over the hypotenuse. If you remember, we can leave it like that, but normally we don't. You normally don't leave a square root on the bottom. So I'm going to times by the square root of 2, times by the square root of 2. So my answer ends up being square root of 2 over 2. Okay, now I have the cosine of 45 degrees equals, so I come down here again, that's the adjacent, which is right here, over the hypotenuse, which is up there. So I go 1 over square root of 2. So again, I'd rationalize the denominator, times by the square root of 2 on the top and the bottom. So they both come out to be the same thing. They both come out to be the square root of 2 over 2. Okay, we're going to skip ahead and just do a couple application problems so you can kind of see how that works. Actually, first, let's solve one of these. Let's do number 3. So it wants me to find out what x is equal to. I know this angle up here, that's going to be my reference angle because I know it. So label your sides. This is the opposite side. This is the adjacent side. And now I've got to decide which trig ratio to pick. So my options are, right, I got the SOHCAHTOA thing. So sine, cosine, and tangent. This is opposite over adjacent. So that's going to be the TOA part. So I'm going to use the tangent. The tangent of 61 equals the opposite side, 22, over the adjacent side, which is x. Okay, solve this. I'm going to times by x. Times by x, those cancel out. X times the tangent of 61 equals 22. Divide by the tangent of 61. Grab a calculator, plug that in there. So we're going to put in 22 divided by the tangent of 61. And it comes out to be about 12.2. So x is equal to approximately 12.2. You can check number 4. If you want to give that a try, you can pause this and work through that and see if you can make sure it makes sense. Okay, let's do just a couple application problems really quick. Okay, so this one says you're measuring a height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation. Hey, an angle of elevation is if you're looking straight ahead, level with you, and then you look up at something. It's the angle that's formed. So that's this angle, like looking straight ahead right here, and then looking up at something. That is an angle of elevation, okay, when you're looking up like that. So the angle of elevation is 59 degrees. We know you're standing 45 feet away from the tree. It wants to know how tall is the tree to the nearest foot. So that, notice over here, that's h. That's what we're trying to find. Okay, so I've got my angle. There's my angle. You got to choose sine, cosine, or tangent. So again, we're doing our SOHCAHTOA. Figure out which one applies. This would be the opposite side. This would be the adjacent side. So you got to use the trig ratio that has opposite and adjacent. That would be the TOA. So we're going to go the tangent of 59 equals the opposite h over the adjacent 45. That should be the equation I can set up to solve this. Now to solve for h. So I'm going to times by 45, times by 45 over here. Those cancel out. So my answer is 45 times the tangent of 59 equals h. Let's plug that in a calculator. So I've got 45 times the tangent of 59, and I get 74.9. So 74.9 feet, approximately. Okay, let's do one last problem. Actually, what I want to do, I'm gonna pause this, or you guys can pause this first. So you have the drawing up there. You pause this, and I want you to try it, and then you can play it again and just check your answer here with what I get. So it says you're skiing on a mountain with an altitude of 1,200 feet. Right, there's my, has it labeled here, the altitude, right, is right there. Okay, it's 1,200 feet. The angle of depression is 21 degrees. Okay, an angle of depression, angle of elevation, we said, is from your sight line looking up. So if the angle of depression is from your sight line right there, looking down. So we call that an angle of depression. Hopefully that makes sense. Elevation is up, depression is down. Okay, it wants to know, find the distance x you ski down the mountain. So it wants us to find this side over here, which they called x. Okay, I always start with your angle. This is my reference angle, which is 21. Okay, decide on the sides. So the 1,200 that I know over here is the opposite side. It's opposite that. The x is the hypotenuse. Okay, so it's right there. Decide which trig ratio to use. So use the SOHCAHTOA. Opposite and hypotenuse is the sine. So I'm going to take the sine of my angle, the sine of 21, equals the opposite side, which is 1,200, divided by the hypotenuse, which is x. Okay, now we just have to go through and solve that angle. So I need x off the bottom of the fraction. So I'm going to times by x to get it off the bottom. Okay, that cancels or reduces that out. Now I have x times the sine of 21 equals 1200. I'm going to divide by the sine of 21. Those cancel out. That's what I'm going to plug in my calculator. So I'm going to grab my calculator. I'm going to put in 1200 divided by the sine of 21. It comes out to be, x comes out to be 3,348.5 feet. That'd be how long you travel down the actual mountain. Okay, the last thing we need to do is work through a problem like this. It says, given that the cosine of theta equals 3/5, find the sine of theta and the tangent of theta. So this is kind of weird because it doesn't tell me, it doesn't give me a triangle and it doesn't tell me any angles. It just tells me what the cosine is equal to. What you'll always do in these problems is draw a right triangle. So I'm going to draw a right triangle. Pick an angle. By the way, this letter right here is called theta. Okay, it's just a Greek letter, but in geometry we use it a lot for angles. So let's put a theta in there. It's just like an x or a y. It's just a different variable. Okay, it tells me the cosine is 3/5. Okay, remember, cosine is the adjacent over the hypotenuse. So the adjacent side is 3. So if I look at my angle, my adjacent side is down here. So it's 3. This is the hypotenuse. This is the opposite. Okay, the hypotenuse then has to be 5. So now I've got two of my sides. I've got the 3 and the 5. I need to find the opposite side over here, which is x. We can use Pythagorean theorem. So 3 squared plus x squared equals 5 squared, and solve for x. Some of you may remember these are actually a Pythagorean triple, but I end up with 9 plus x squared equals 25. So I minus the 9 over. X squared is equal to 25 minus 9, which is 16. Take the square root of both sides. So x equals plus or minus 4. It's talking about sides of a triangle, so it's just a positive 4. So I'm going to come up here. This side right here then is a positive 4. Okay, now it wants me to find the sine and the cotangent. So all I do is the sine of theta. Right, here's my theta. Sine is opposite over hypotenuse, so the answer is 4/5. I'm done with that. Tangent of theta. Tangent is opposite over adjacent, so it's 4/3, or 4/3. Okay, so I've got my two answers right there. Okay, let's just do one more of those really quick, and then we'll call this good. So it says, given the sine of theta equals 5/13, find the cosine of theta and the tangent of theta. Okay, so draw your triangle. Put your make it a right triangle. Put your theta in one of the acute angles of the triangle there. Come back up here. Make sure you know sine is opposite over hypotenuse. So if this is my angle right here, the opposite side is 5. The hypotenuse is 13. We've got to find this missing side down here. So just use Pythagorean theorem. We got x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169 minus 25 over x squared equals 144. Take the square root. X equals 12. So we're going to put a 12 here. Okay, now I've got all my sides. I just want to know, what is the cosine. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. So 5/12. Okay, so there's your introduction to sine, cosine, and tangent, and we can use those ratios to solve triangles or to find missing pieces of right triangles. Feel free to go back and watch the video in any parts you need to. If you have questions as you go through the assignment, keep track of what numbers, and we'll do a question answer that I'll post onto Canvas tomorrow. So let me know about that. Good luck.